Hello, AP Chemistry. How are we doing today? Hopefully, y'all are doing well. Today, we are actually going to be finishing up our Unit 7 notes on equilibrium, and we're going to be doing that with common ion effect and pH. Now, this is actually going to be Unit 7.12 and 7.13 on the College Board website. So that would be where you can go to do some practice on this. So for this, we are going to be talking a little bit more about the common ion effect. Now, we do know that if y'all did the POGIL last class, the common ion effect is basically showing a relationship that we can see in a reaction when we have common ions and how that will overall affect what happens in that reaction. So you do need to keep that in mind. If you have not, please go back in, rework through that or work through that POGIL. Make sure you've done that because that is going to be a big important thing to kind of help you along with this lesson today. Now, we are also going to cover pH. Now, for pH, you do need to know neutralization. So what is neutralization? Basically what it is when we take an acid and a base, we're going to produce water and salt. Now, remember, salt can be any ionic compound. Now, the net ionic for your strong acid and strong base would be us producing or taking a hydronium, which a lot of times is sometimes also represented by just a hydrogen atom, plus hydroxide. And we know that when we take those two things, we are going to produce water. All right. Now, some things to note is that, remember, when we've got our QSP and it is less than our KSP, we are going to shift to consume reactants. And if we're shifting to consume reactants, we are going to form some more products. Now, if I've got a Q that is greater than my K, we're going to do the opposite. So we're going to consume some products to form some more reactants. All right? Now, so the effect of pH on the solubility of an ionic compound. First thing, when one of the ions produced in an equilibrium is a hydrogen or a hydroxide, pH can influence the level of solubility of that solution. Okay, so if I've got a hydrogen ion or a hydroxide ion that's being produced, pH can affect my solubility. All right, so let's look at what it will do. So if I increase my pH of a solution, that's going to make the solution more basic, right? That's going to mean that we're increasing our hydroxide ion, right? So as I add and as I increase my pH, I am becoming more basic. And remember, the more basic the solution, the more hydroxide ions you have. Now, if I decrease my pH, then what I'm doing is I'm making that solution more acidic, which means that the concentration of my hydrogen ions is going to increase. All right. So if I add more, or if I make a solution more acidic, I'm going to increase my hydrogen concentration. So we're going to have to look and see how that's going to affect it, because when you add an ion that is currently present in the solution, we're going to shift based off of our common ion effect, right? And so in the case of acids and bases, adding the opposite ion is going to cause a neutralization reaction to occur. And so we're going to create some water. Now, what's going to happen there is then we're going to have to shift to form some more products. Why? Because now we've got some more space for those ions to be produced, which means we're going to shift to that right side, shift to the product side, and we're going to see some more products being formed. So the solubility would be increasing. All right. Now, so here's some examples. So if I've got compounds such as calcium hydroxide or calcium carbonate, the solubility is going to vary based off of the pH of the solution. Basically, we know that hydroxide and carbonate are bases. So using Le Chatelier's principle, we can predict how the solubility is going to change based off of how we affect our pH. If we raise our OH concentration, how will that affect? We're adding some more to the product side, so we know based off of Le Chatelier, we would shift back to that reactant side and we would cause some more reactants to be produced. Okay, so let's take a look at this and let's see how this would affect our solubility by changing some of these things here. So if I've got calcium hydroxide, and we know that it's a strong base, and so it dissociates into the calcium ion and two hydroxides there. So if I lower the pH of the solution by adding a strong acid, HCl, what is that going to do to my solubility? Now, well, think about what does adding HCl actually add to this reaction? Well, it's going to increase the amount of hydrogen ions. Okay, so we're increasing our hydrogen ions. Well, those hydrogen ions are going to react with our hydroxide ions and neutralize them. And so as a result, we would get some more product, right? Or sorry, some more water. Now, I'm neutralizing that, right? So I am actually reducing how much product I have. Well, we know based off of Le Chatelier's that if I decrease my product, what am I going to have to do to restore equilibrium? Well, I'm going to have to consume some reactants to form some more product, right? So I'm going to have to shift to do that. Now, if I shift to consume more reactants, what does that mean in terms of solubility? Well, what it tells me is that I am increasing how much of that calcium hydroxide can actually dissolve, right? So I am increasing the solubility if I add some strong acid to it. So we're going to see an increase in solubility. Okay? And I'll actually write that out on your notes key later, just kind of that explanation of what's actually going on. All right? Next thing, what would happen if I raise the pH of the solution by adding a strong base, which is sodium hydroxide? Now, in this case, what am I adding to the solution? Well, I'm adding hydroxide, right? And so as I add some more hydroxide, I'm adding more to my product side over here. So now I've got more products. If I've got more products, what happens with, based off of Le Chatelier's, I'm going to see a shift, right? And so I'm going to see a shift to form more reactants, all right? And that would result in a lowering of the solubility, okay? So because less of that calcium hydroxide would actually be able to dissolve. So we're going to see a decrease in solubility. All right. So last one here. Would magnesium hydroxide be more soluble in an acid or a base? So based off of everything that you've just learned, I want y'all to pause your video, solve this problem, and then we're going to go over it. All right. So pause your video, solve the problem, and then we'll go over it. Okay, so what you should have ended up with is that magnesium hydroxide would be more soluble by adding it to an acid, all right? And that would be because by decreasing the pH, we would have more hydroxide that was able to be consumed in the neutralization reaction, which would then in turn result in an increase in the solubility of that reaction, all right? So y'all, that is it for equilibrium. As always, let us know if y'all have any questions, but otherwise y'all have a great rest of the day. Bye, y'all.